Okay, imagine our program, our command line tool gets traction. It's being used by people. And it doesn't take long before a first complaint comes in. A user from China is complaining that if they are using input in their language, they get an error. And it's true, we confirmed there is some problem. And if you look carefully, we can see the problem is on line 39. At least it looks like it's on line 39, but it's definitely in the reverse function. First thing, let's split or let's move the function into a separate package so we can test it more easily. I'll create a new folder here called reverse. Inside I'll create a file called reverse.go, which is package reverse. It's a sub package of the hello package. And I'll move this code there. Let me rename it to string so it makes sense, like a reverse string. I also capitalized it because otherwise we wouldn't be able to see this function outside of the reverse package. And now I will use it here, reverse string, and if I save, I can see the hello reverse sub package was imported automatically. Let's try to build and run again. Okay, we get the same error message. Before trying to fix the error, let's write a test. Reverse test.go, package reverse, so it's the same package. And the way we write tests in Go is we do test and then some description of the test, for example, the function name we are testing. And we need to use this as the argument. It's a standard library package called testing. So the input was this. What we expect or what we want would be probably these two characters swapped or reversed, sorry. Like this. And what if what we got is not what we want, we raise a error from the test. It's important to make the test errors descriptive or understandable. Let's try to run the test. Okay, we can see the test is failing. So the test string failed with the same error as before, runtime panic. Good. So now we are ready to tackle the issue. So let's have a look again at the string function. So the problem is somewhere here, and the error message says index out of range. So we are looking for an element at index 5, but the slice has length only 2, so there are only 2 elements in the slice, and that's why we get runtime panic. What's going on here? If you look carefully, I'm working with the rune slice here, but here I'm working with the string, and string is slice of bytes, while slice of runes is, let's say, slice of characters. It's more complex than this. There is a blog post from the Go team from Rob Pike. I recommend you read to understand strings, bytes, runes, and characters in Go. But for our purposes, I think it's enough to say that strings, when you index strings, they yield bytes, not characters. And this string has 2 characters, but it has 5 bytes. Because one character is encoded by 3 bytes and the other one by 2 bytes or something like that. So the fix is probably to use runes here for measuring the length. Let's see. Nice. So we have fixed the bug. But let's put some more tests, and we'll use something called test tables. So first we define how our test data should look like. So it will be a struct, slice of structs with 2 fields. One is input of type string. The other one is what we expect as the output. It's also a string. And we can create our first data. So the input is this, and the output we want is this. Now we can loop through the slice of tests, range tests, and we change this to test input. It's this field. Test want, and also here test input and test want. Let's see. Cool, it's working as before. So the advantage is that now we can add more test cases. For example, hello world should be what should it be? Like the LROW OLLEH. Let's see whether it works. No. So we got this, but we want this. Okay, the problem is no comma, so the comma goes with hello, so like this. So I had an error in the test right now. So I fixed the test. Okay, nice. And let's add an edge case. So if the input is an empty string, we expect empty string as output. Let's see now. Cool. One last thing. Let me show you how to set up logging for command line tools. First, let's do some logging. So let's say if the user supplies an empty string as the name, we consider it an error. So if name equals empty string, we log an error. Name can't be empty. And let's see how it looks on in the terminal. So we build the package. We do empty string as input. Name can't be empty. This we don't need the timestamp. We would rather have the name of the program that has created this log message, and we do it like this: log set prefix 0. No, sorry, log set flex 0. This removes the timestamp, and log set prefix hello. This sets a prefix for the log message. Let's try to build and run it now. Okay, this looks nicer.